Good morning students. I welcome you all to my online class on dynamics. So today we are going to solve few problems based on components of velocity and acceleration along tangential and normal direction. So let's start with the first problem. If a particle moving in a plane curve has acceleration a, show that the normal acceleration is given by magnitude of it is vector a cross t cap. T cap being the unit tangent vector at the point considered. Also show that the tangential acceleration is vector a dot t cap. So here acceleration is denoted by vector a, and we have to show that the normal components of acceleration is given by the magnitude of the cross product of vector a and t cap. So in order to get this results, we have to take the help of the expression of acceleration. So just to see what is the expression for acceleration. Acceleration we can write it is v dot t cap plus v square rho by n cap. So already we have obtained the results for components of velocity and acceleration along the tangential and normal direction. So this here v dot will give you the normal acceleration and v square by rho will give you the normal v dot will give you the tangential acceleration and v square by rho will give you the normal acceleration. So vector a we can express this way, it is a t cap. At will denote the tangential acceleration plus an n cap. An will denote the normal acceleration. So if we take the cross product of equation 1 with t cap, then what you will get, it is vector a cross t cap. So we are taking the cross product post cross product, so from the end, so it is vector a cross t cap, and right hand side you see if you take the cross product with t cap, here also t cap, and you know in case of cross product of two same vectors is a zero vector, and cross product of two different vectors you will get a vector perpendicular to the plane of those vectors, and the direct and if the turning tendency is clockwise, then the vector will be negative, and if the turning tendency is anti-clockwise, then the resultant vector after taking the cross product you will get positive. So here if you take the cross product with t cap, see left hand side it is vector a cross t cap, right hand side see t cap cross t cap will be 0, and here what will get a n keep as it is, so n cap cross t cap. So if you take the cross product of these two vectors, so from n cap to t cap you will get the clockwise direction, so result of this will give you the unit vector, so it is minus k cap, this minus sign because the turning tendency is clockwise. So from this what you will get, the cross product of vector a and t cap you will get a n then minus k cap. So now take the magnitude of this. So if you take the magnitude to the right to both sides of this equation, it is the magnitude of vector a cross t cap is equal to right hand side what you will get, it is a n, because magnitude of the unit vector you will get 1. So this is the expression for normal acceleration. So normal acceleration in this case it is given by the magnitude of the cross product of vector a and t cap. Okay, next let's take the dot product of this equation 1 with t cap. So if you take the dot product, see vector a dot t cap, so you know in case of dot product t cap dot t cap you will get 1. So here what you will get, and t cap dot n cap you will get 0. So from this you will get vector a dot t cap, it is at. So the tangential acceleration is given by what, it is the dot product of the vectors a and t cap. So this way we can obtain the normal acceleration and tangential acceleration. Now let's move to the next problems. If a particle has velocity v bar and acceleration a bar along a plane curve, prove that the radius of curvature of its path is given by rho is equal to v cube by magnitude of v vector v cross vector A. So here we have to take the help of the expression of the tangential and normal components of velocity and acceleration. So we can start this way. So we have, what is the expression for v var? So already we have obtained this result. The expression for v var is equal to what? It is v t cap. So here v is the tangential velocity, and the expression for acceleration is what? It is v dot t cap plus v square by rho n cap. V dot is the tangential acceleration and v square by rho is the normal acceleration. So if we take the cross product of vector v and vector A, then what we'll get? So take the dot product of these two. So we'll get, see, vector, for vector v we can write v t cap cross, for vector A we can write v dot t cap plus v square rho by n caps. Now in case of cross product, you know that t cap cross t cap, you'll get the zero vector, so this part will vanish. Now if you take the cross product of these two, you'll get v cube by rho, then t cap cross n cap will give you k cap. K cap is the unit vector perpendicular to the plane of t cap and n cap. So here the turning tendency is anti-clockwise. So if you take t cap to n cap, the turning tendency will be anti-clockwise, so it will be positive. Now after taking magnitude of this, what you will get? The magnitude of vector v cross vector A will give you v cap by rho. So from this, if you simplify rho, you will get it is v cube by magnitude of vector v cross vector A. So this way we can prove that the expression for rho is equal to v cube by magnitude of vector v cross vector A. So thank you. Next class we'll solve two more problems.